Now in the previous lecture, we have implemented a linear queue using array. Now starting from this lecture, we are going to learn another type of queue, which is circular queue. Now here, the question is, why do we need circular queue? Now when it comes to the linear queue using array, we have some problems there. The problem is, when we are dequeuing the elements from the queue, the method causes blank cells over here. So this means that, let's say we have a queue like this, and in which we have 3 elements. Now here, if we implement it using array, our array will be like this. Now when we are dequeuing the elements from the queue over here, it's going to return the first element from the queue, and then it's going to update the beginning of queue, which will dismiss this cell over here. Then if I call the queue method one more time, it's going to continue to the second element. So in this case, the second element will be the first element in our queue. So that's why it's going to dismiss this element from over here. Now the problem is, when we are doing so, every time we are changing the beginning of cell, these cells are dismissed. So this means that we are not going to anymore use these cells over here until we reach the end. Because if I enqueue the elements over here, it's going to enqueue after 30, so these cells over here becomes empty. So this is not space efficient solution over here, because every time we will have blank cells over here. Now you might be interested that when we reach over here, we can use these blank cells over here, but in the case of linear queue, we cannot do that. Because as you remember, when we are implementing the linear queue, we said that when the top of the queue is reached to the length -1, length of array -1, in this case we are returning saying that the queue is full. Now let's really look at this in the real life example. Now over here, let's say we have a queue like this and we have 3 elements over here. Now the top of the queue is obvious that it's at the index of 2. Now if I enqueue one element over here, we are going to increase the top of queue to point to the index of 3 over here. So it's going to be increased by 1. Now if I enqueue one more element over here, the top of queue will be increased by 1, so it's going to be at the index of 4. So if I continue it like this and insert an element to the 5th index over here, it's going to be like this. The top of queue is 5 now. Now according to our isFull method, it's going to check that if the top of queue, which is 5, is equal to length of array -1, so in our case length of array is 6, so 6 minus 1 is 5, so in this case we are going to return true, saying that the queue is full. Now in this case it's returning correct because our queue is full. Now the point is, if I call one more time the queue method over here, it's going to dismiss this cell from here. So if I call it one more time, it's going to dismiss the second cell from here. But in this case, if I call enqueue method one more time, in this case it's going to check one more time top of queue. So it will see that top of queue is still equal to the length -1. So in our case length is 6, so -1 is 5, so it's going to equal to 5. So this means that it's going to return true, saying that our array is full. But in reality, our array is not full because we have 2 empty cells over here. So we have to somehow use these empty cells over here to make our solution more efficient. But in case of linear queue, it's not possible because we are not doing that. Now to solve this problem, we have 2 ways. Now one way is, when we are dequeuing elements from this queue over here, every time we are shifting all these elements to one step left. So whenever we are dequeuing the element from this queue over here, every time we are going to shift the elements to the left. Now in this case, the time complexity of dequeuing element will become O(n), because every time we have to move all elements one step left. So if we have n elements, it's going to be O(n) time complexity. So this is also not efficient solution. So we have to do some way that the queue element must take O(1) space complexity. Now this problem is solved using circular queue over here. Now by using circular queue, we are going to use these empty cells over here, and our dequeue method will take O(1) time complexity. Now in the next lecture, let's see how we are going to do using circular queue. So basically the reason that we need circular queue is that when we are implementing linear queue using array, the queue method causes blank cells over here, so this is not space efficient solution. That's why to make these blank cells reusable, we need circular queue, and in this case we have to do it in a way that the time complexities are not changed. So let's see how this is working in the next lecture.